Welcome to clickmyproject.com. The title of this paper is The World in a Nutshell, Concise Range Queries. This comes under the domain data mining. The main concept of this is to deal with the spatial databases, because spatial databases have witnessed an increasing number of applications recently, partially due to the fast advance in the fields of mobile computing. For example, it is quite common these days that people want to figure out the driving or walking directions from their handheld devices like PDAs. However, facing the huge amount of spatial data collected by various devices such as sensors and satellites, and limited bandwidth and or computing power of handheld devices, how to deliver light but usable results to the clients is a very interesting and of course challenging task. Our proposed work challenges to this task. Our work has the same motivation as several recent work on finding good representatives for large query answers, for example representative skyline points in that existing system. However, facing the huge amount of spatial data results to the clients is a very interesting and a challenging task. General query processing for large relational databases and OLAP data warehouses has posed similar challenges. In view of this problem, we present a novel idea that a concise representation of a specified size for the range query results. It achieves minimal information loss, shall be computed and returned to the user. This concise range query technique not only reduces communication cost but also offers better usability to the users. There are several existing work has the motivation on finding good representative for large query answers. General query processing techniques were also proposed. In fact, scalable approximate query processing with the DBO engine argued to return concise representation of the final query results in every possible stage of the long-running query evaluation. Some other techniques have also been used for dealing with spatial query processing. They are as follows: basic normal clustering techniques and random sampling methods. These methods have some drawbacks. Existing clustering algorithms does not provide a good and concise representation of the point set. It may cause information loss or information overloaded problems. The existing works may be a time-consuming process. It is difficult to devise more effective approximate representations for their results. So, in order to overcome all these challenges, our proposed work came into existence. Now I will explain the proposed work of our project. The proposed work initially processes with the user given query. For example, the landmark query is processed with the given document set that contains the spatial data and landmark details. From the document set, the relevant document to the query is retrieved for further processing. That particular document is taken for finding the similarity between the data contained in that document. Similarity in the sense textual similarity will be computed. Textual similarity in the sense the similarity between the words that are contained in the document will be founded. For that, we will use the Palmer measure that calculates relatedness by considering the depths of the two synsets in the WordNet taxonomies along with the depth of the LCS. An equation will be used. The similarity between word 1 word 2 equal to 2 into most informative subword divided by depth of the first word plus depth of the second word. This is the similarity measure for finding the similarity value between two different words. By using this technique, we will find out the similarity between the words in the document and we will form clusters. The clustered result will find the result according to the landmark given. For example, the most similar data are clustered together to obtain the result of query with respect to the given kilometer. Kilometer in the sense the user query. For example, if a user searches for a landmark within a particular kilometer, the landmark value will be taken as a initial query, and it will be considered as the first keyword, and the kilometer will be taken as the second one, and the similarity is calculated according to that. The user given kilometer is searched within the clusters, and the data with the specified kilometer is retrieved. After that, we will perform the spatial relevance. For finding the spatial elements, we will use the IR tree algorithm. An IR tree algorithm is a tree-based algorithm that satisfies the following properties. Every leaf node contains between m and m index records unless it is the root. Thus, the root can have less entries than m. For each index record in a leaf node, I is the smallest rectangle that spatially contains the n-dimensional data object represented by the indicated tuple. The root node has at least 2 children unless it is a leaf. Likewise, it has many more properties for creating an IR tree. Then the values given in the cluster or in the document will be inserted into the IR tree. Inserting index records for a new data is similar to inserting into a B tree. New data is added to the IR tree leaf nodes that overflow or split, and splits are propagated up the tree. The insertion algorithm is more complex than the searching algorithm because inserting needs some help methods. After inserting, we will be finding the spatial relevance. The spatial relevance of a document D depends on the types of the spatial relationships defined between a document location, that is the landmark, and a spatial scope S. The areas specified in the spatial relevance are as follows, that is enclosed, overlapping, and proximity. After finding the spatial relevance, the search engine results will be followed, and the search engine results retrieves the best relevant document or relevant answer to the given query. This is the proposed work of the project. Now I will explain the system architecture of our proposed project. The first one is the user query, that is the landmark. The particular landmarks document will be collected from the spatial data set, and the relevant document is retrieved here. After retrieving, we have to perform textual similarity and spatial similarity. Textual similarity is found out and the clusters are formed. According to the kilometer, the cluster results will be displayed here, and the spatial similarity is calculated using the IR tree, and the location scope value is returned to this. Combining both cluster results and the scope value results, the top k documents or the top k answers will be retrieved to the user. Now I will show the demo of this project. For that, we need NetBeans and WAMP server. After starting the WAMP server, click home.java and click run file, and the form will get opened. In that, we have to give the load, in the sense we have to load the query. For example, restaurant within 3 kilometers, and click go. Show the document will be shown here. For that, we will be calculating the TF and IDF values, and we will perform clustering operation with this, and the show and the places will be shown according to the cluster value which is most relevant to that. And for finding the spatial relevance, we have to click load. In that, select the corresponding file, that is dataset nutshell restaurant.txt, and the corresponding tree will be drawn. If you click query and circle query, click OK, the corresponding portion will be extracted from that entire document set, and the query result will be displayed here, and the constraints range will be displayed here. After performing that, we have to calculate the spatial relevance value, that is the location scope value. It is represented here, and the search results will be displayed here, and the most ranked hotel is displayed here. And if you click show details, then the landmark in that particular hotel will be displayed in the Google map. If you click, it will be getting opened in this. After that, you have to click Hotel Germana. If you click this, then the result will be displayed here. It is displayed here. That's how now our project ends with this. And if you want to click show, if you want to perform the graph operation, then it is shown here. Our project ends with this. Thanks for listening the video. Thank you.